What changes will we anticipate when we move from Gen AI to Agentic AI?
Yeah, that's a really good question. And, I like to think of this as, generative AI was the area of chatbots and having a conversation, whereas agentic AI is more of the era of much more automation and sophistication. So there's two real big changes that happen when we shift to agentic AI. The first is really the amount of work that the AI can accomplish in a single go really expands quite dramatically. The agent has access to these tools that it can use to look up, what are some relevant engineering artifacts that I might need to, you know, load into my memory to answer this question. It can search for documentation. It can execute code and run simulations, and you can, respond to the results of doing all of that. And so it really opens up a lot of really exciting possibilities. And kind of at the core of this is the agentic loop. And so the user defines some success criteria, that maybe the agent implements that, and then the agent is just going to iterate around this loop of like planning, acting, assessing the results, and then iterating until it's met those success criteria. And so the result is that the agent can tackle larger problems. They can really perform some level of verification even themselves. They might come up with test cases and run those. And so bigger problems and higher result quality. So that's like one big change. The second big change, though, is that more of the conversation shifts from the engineer's head to the agent. And so historically, like engineers, when we write code or work with models, like it's a very iterative process. Every time I make changes, I'm testing that out. I'm learning what works. I'm learning what doesn't. And I'm developing a ton of intuition in my head about how does this thing work. When that gets delegated to an agent, a lot of that conversation actually leaves the engineer's head and it's kind of contained within the agent. And so there's this like challenge now that the engineer is still responsible for the final thing that comes out of it, but they don't have as much intuition about what it is. And so it's a challenge that we're seeing a lot of engineers start to tackle, but it's like there's no obvious silver bullet there. In the end, the engineers still need to be responsible for the work.
Right, of course, because engineers are trained to verify results, right? Not
Yeah.
simply accept answers. Um, so how do you build trust in agentic AI systems?
Yeah, I think there's a couple ways you can do that. So one, you need the output of the agent. So whatever the artifacts are that the agent is creating to be in some type of format that the engineer can easily understand. And so for us, that means higher level abstractions like MATLAB code and Simulink models. It's things that the engineer can quickly wrap their head around and reason about their behavior. So that's like one part of it. And the other part is really, verification and testing. Engineers need to be able to take whatever the artifacts are that the AI generated, run simulations, verify performance, run different scenarios through them, and really analyze the results coming from those, so that they can make sure everything's working as expected. It's really the outputs coming from the agent are non-deterministic, but the engineer needs some type of deterministic process for evaluating the results and making sure that that thing that came out is actually sufficient.
Okay. So what are the biggest risks of agentic AI in engineering environments, and how can they be avoided?
Yeah, I think getting back to a little bit about what we were talking about earlier, like there's a phrase I've heard called cognitive debt, and it's like the the agent has more of the conversation and more knowledge of the system than the engineer does, and that can lead to maintainability issues. So longer on down the run. So the engineer still needs to be very involved in things like architecture and understanding at a high level what are the big pieces, how are they implemented, how are they connected. One, because I think engineers can often anticipate issues that might arise from like a poor architecture, but then also the engineers have in many cases lots of years of domain expertise about how to build these types of systems, and they've maybe went down some of these paths already themselves that the LLM might think is or the agent might think is a good path, but the engineer kind of knows better based on their experience. And so I think that's certainly an issue. And then the other risk is, of course, agents do make mistakes from time to time. Hallucinations are still a thing. You still have to watch out for mistakes. And so for that, you really just need to make sure that the engineering process is very well defined. You're going to want to have guardrails of some case that limit what the agent can do, what changes can it make, make sure that it's behaving as you expected. And then you also need things like version control systems and being able to revert changes if, because it's still possible that these agents start making changes and hit a dead end. And so being able to revert back to like a last known good type of a scenario can be really important too.
Right. So do you think that agentic AI will fundamentally change the role of engineers, or mainly change how engineers spend their time?
Yeah, really, really interesting question, I think. And I think we're all still kind of watching this play out. But from my perspective, I don't expect that the engineering process itself is going to change all that much in the short term. And so, we still need to identify problems. We need to define requirements. We need to, propose solutions that can solve those problems and verify that they're doing that. And so I don't expect the process to change much, but I do think where engineers spend their time is changing and is going to change more. The kind of sweet spots where we're seeing that already change the most are places where the work is tedious. So not all engineering work is glamorous. There's tedious work, and the AI is relatively strong too. So if you have both those things are true, then there can be a really good fit for delegating more of those things to the agent. And so use cases that we've been encountering are things like testing, debugging, documenting how a model or a system works. Those are parts of the workflow that can be very repetitive. They're also places where maybe it's about writing a description of what's going on, and agents can do often a very good job looking at some engineering artifact and writing a description and explaining it because they have such broad knowledge. We're also seeing a lot of interest in workflows around legacy code that a lot of our customers have. They have these algorithms that have been there for many years and they just work, but they're trying to either modernize them and integrate them with their modern infrastructure, and so they need to extract requirements from those because maybe they don't even have requirements defining how that code works, or maybe they have some requirements but they need to link the code to the requirements so that they have traceability through their engineering processes. So those are other I would call sweet spots where there's a lot of opportunity to improve the engineering workflow. Again, not changing the process, but engineers can spend less time there. And then, I think kind of in an ideal scenario, this is going to lead to engineers having more time to spend on other things, right? And so, more time to evaluate different design alternatives. Maybe hopefully leading to more robust designs. You can spend more time on, what are the higher level design goals, design options, maybe evaluating some different alternatives that they didn't have time to in the past, as opposed to spending more time on some of the lowest level implementation details.
Right. Yeah, that sounds like good news, having more time to problem solve. So
exactly. Yeah.
Yeah. So if we have this conversation again in 5 years, what do you think engineering workflows will look like then?
Yeah, that's a fun question. I think the biggest thing is the role of the engineer is just going to continue to be more and more elevated in the engineering process. And so, this is a trend that's been playing out across decades or better halves of centuries, where we've went from having to do things with math by hand or slide rules to different generations of programming languages that have made things in higher and higher levels of abstraction. And I think generative AI is causing a shift or a move to yet another level of abstraction. And so I think because engineers will be able to delegate more of that low-level work to the AI, it means that the engineers who are going to be the most successful, I think, are going to be the ones that can, successfully navigate that change and then really elevate their skill set to focus more on how do I clearly define what my design objectives are, what my constraints of the offering is that I'm trying to provide. And so instead of directly shaping the product or the solution themselves, they're almost more shaping the design space that the agent can explore. And so it's like, how do you shape, how do you tell the agent everything it needs to know to come up with, good solutions that solve your problem, and then let the agent do that iteration for you. And so you're operating at this higher level, defining objectives, defining constraints, and then delegating work to the agent. I think that's kind of the future that we're moving towards. We've been seeing some trends like that play out with reinforcement learning over the past decade or so, maybe half decade, where we're starting to see this use of AI, and the engineer defines some type of environment that the AI can operate in, and then that the AI optimizes to come up with a good solution in that space. And I think more and more engineering is going to start to look like that.
Great. Sounds exciting. Thanks so much.
Yeah, I think so. Yeah, thank you.